All right, let's take a look at a few more examples together involving the Pythagorean theorem. Tell if the measures can be the side lengths of a triangle. And if they can, let's classify the triangle as acute. It's so acute. All the angles are small. Whether it's obtuse, one of the angles is bigger than 90 degrees, or if in fact it is correct. I mean, right. All right, so let's take a look. Here I see 5, 8, and 10. How do we know if they actually form the sides of a potential triangle? We see if the triangle inequality is satisfied. Namely, every pair of side lengths should sum to a number that exceeds the third. So let's take a quick look at this. 5 plus 8 is 13. That exceeds the third length, 10. 5 plus 10 is 15, which exceeds the third length of 8. And finally, 8 plus 10 equals 18, which exceeds the third length of 5. So yes, we have a triangle. Houston, we have a triangle. And now the question is that triangle obtuse or so forth? Well, let's take a look and see. Notice that if we try sort of to make the Pythagorean theorem hold, let's take a look at 5 squared plus 8 squared. Take the two smaller sides, square them. If that will equal the square of the third side, then the Pythagorean theorem holds, and we know that it's actually going to be a right triangle. And if not, then it'll either be acute or obtuse. Let's take a look. Here we see 25 plus 64, 25 plus 64, and that equals 89. Now, how does 89 compare to 10 squared? Well, that's 100. 89 is smaller. So that means that the sum of the squares of these two sides is going to be smaller than in fact, the third side, which means that the third side needs to be sort of bowed out a little bit. So the picture has to look like this. 5, 8, 10. Because this squared plus that squared isn't enough, right? That to be a right triangle, the 10 is longer. So it pushes, the 10 bullies its way into this triangle. Boom! And it forces this angle to be quite impressive. And so, in fact, this is greater than 90 degrees. This is an obtuse triangle. It's an obtuse triangle. Let's try one more together. Here we go. Very nice. Let's see, first of all, that it's a triangle, and then we'll see what kind of triangle it is. So we'll take 2.3 plus 7.2, and that equals 9.5. Now, wait a minute. 9.5 is not greater than 9.6, as is required by the triangle inequality. This is wrong. This is false. So, in fact, this is not even a triangle, because, in fact, the sides can't sort of meet together to make that triangular peak-shaped region. In fact, the thing collapses down onto a line. So, in fact, this doesn't work. It is not a triangle at all. And that's a sad way to end such an uplifting lecture. So let's throw that all away, throw it away, and let's just focus on the beauty and the simplicity of the Pythagorean theorem. When we have a right triangle, you take the length of one leg and square it, add to the length of the other leg and square it, and in fact that will always equal the length of the hypotenuse squared. Wow.